So I would like to pose the following task. Here is something that I would like you all to do. You can walk together. Group size is unlimited. I'm not going to collect it or nothing. We'll talk about it in just a bit. Claim. Let A and be a convergent sequence. Let A be its limit. Then, I don't know, negative 6 an minus plus 5. There's a new sequence. Converges to, and I don't know, what should that converge to? If an gets close to a, then where do you think that sequence should get close to? Well, just think very intuitive, yeah. Not too extreme. So an itself is getting really close to a. So an is a sequence. You don't know what it is. You know it converges to a. You don't know what a is either, but it's a number. So if an is getting close to a, where should that get close to? Negative 6a, and then there's actually like plus 5 or something, right? Okay. It does. Yeah. So right, like if it were just a plus 7, if a gets close to 5, then a plus 7 should get close to 12, right? It's like the addition there does matter. Here is the proof. I would like you to compose a proof. And in fact, I am going to suggest starting with just some scratch walk for the proof. So what are you going to try to do in the scratch walk? You're going to try to go for so try to control negative 6an plus 5 minus negative 6a plus 5. Try to control that in terms of the thing above. I think I'll suggest starting with is just do some stuff to that. Simplify it. See what you get. together. So when you take that thing that I wrote in orange, you just like simplify it. What do you get? Yeah, say what you said.
I know you've got -6. I like the absolute value of -6 and plus 6 out.
Uh-huh.
And then I just pull the 6 out. And it was like and plus a. But it's,
One of them better be negative, right?
oh yeah, but it's absolute value, so.
Cool.
And then that's less than epsilon. So then if you divide this by 6, you get it's less than epsilon over 6.
Nice. So you eventually get it less than 6 times whatever it is that you put in that box. You can put any positive thing you want there. And as you pointed out, if you want this whole thing to be like epsilon, it looks like epsilon over 6 will do the job. Cool. I feel pretty all right. So, what does this tell us? This tells us the hard parts of the proof to write up, and it tells us like the choice we need to make. So now I think, what do you think? Are we ready to actually write the epsilon n proof? A lot of this like epsilon n proof has the language pre-packaged. So, is the doc time big enough to have like both up? Basically. So let's try to compose this proof. So we know, like, let's start with the setup, like give the assumptions. Let's let an converge to A. We want to show -6an plus 5 converges to -6a plus 5. And how do you write down any epsilon n proof? Well, you better start with consider any epsilon bigger than 0. Next comes the step where you try to come up with your choice of big N. And we don't have enough information that we can just say let big N be blah. But we do have an assumption. We know that an converges to A. Since an converges to A, there exists some big N such that for all little n bigger than big N, absolute value an minus A is less than, and I can put any positive number I want on the other side of that inequality, as long as that positive number doesn't depend on big N, doesn't depend on little n. So what positive number do I want to put there? The thing that the scratch block told us. All right, so that gives me a choice of big N. So the anatomy of like an epsilon n proof, I considered any epsilon bigger than 0. I came up with my choice of big N. Now I have to let little n bigger than big N. Then absolute value of -6 an plus 5 minus -6 an plus 5 I need that to be less than epsilon. So, right, the thing you taught in doesn't include the scratch block, but talk me through why is that less than epsilon?
Is this supposed to be an on the second row?
Nope. And of course, that's the one thing that I chose to write, not the erasable method. So if this were like a homework write-up, I would now have to finish this and then get a new clean piece of paper so I don't have anything ugly like that in this. I'm not holding it. All right. Tell me what, you need to convince me that that is less than epsilon. Let's go through step by step. So. And like all of the just like pure algebra steps, we can do it all at once. Right, so what is that equal to?
I guess the next step would be the absolute value of -6 plus 5 plus 6a plus minus 5.
Oh, sure. Cool, and I guess that's like by distributing. And now let's carry on from there.
I know it's like the easy steps, right? Like, what next?
Would be the absolute value of -6 plus 6a with the 5's cancel.
By canceling. All right, what next?
Oops.
You follow the -6.
With an absolute value around it. And that's by some properties of absolute value. We can do that. All right, what next?
The absolute value of -6 is just 6 times the absolute value of a minus a.
All right, what next? Well, everything's been simplified all the way out. So there's no more simplification to be done. Now is time to use the choice that I made. Yeah.
Then you just compare it to like I think it was like the big N, right?
So, in a sense, we can use the fact that we know that little n is bigger than big N, because there is a little n bigger than big N. And we chose this little n for a reason, right?
So since little n is bigger than big N, what do I know?
A minus A is less than epsilon over 6.
A n minus a is less than epsilon over 6. So I can't like do some jiggery pokery with like an algebraic formula at this step, because I don't have an algebraic formula for a n or a.
But what I can say is that that is less than 6 times epsilon over 6, since little n is bigger than big N, so absolute value a n minus a is less than epsilon over 6. All right.
What next?
Then you can just simplify it out where it would be less than epsilon.
Yeah.
That would be with epsilon.
Yeah, I think I like an equal there because you're saying this is equal to that. So, for all epsilon bigger than 0, because we started with a consider any epsilon, we didn't explicitly say what big N is, but we did get there to exist a big N. There exists a big N such that for all little n bigger than big N, absolute value of gosh, negative 6an plus 5 minus negative 6a plus 5 is less than epsilon. So, and you know what the rest of the sentence is going to be, right? Say what the thing you proved. So here's an epsilon n proof, even when you don't have a formula for what an is. When you don't have a formula for what an is, you won't get a formula for what big N is. Instead, you have to look at your assumptions and get some existential comment about big N out of it. How did that feel? Does that feel okay? Nice. Maybe I'll even suggest this proof has some steps that I wouldn't need to see. I would be perfectly happy if you skipped all that and said, by simplifying. It's only not wrong to include every one of those lines, but I know you can do algebra. If like you do that and it's just wrong, then I'll like be a little concerned. But I don't need to see the line by line. You don't need to explain what field axioms you're using at this stage. If you do, then every proof is going to be like 10 pages long. And you don't want to write that, I don't want to read it. Nice. Hopefully this like felt good. All right, let's ratchet up the challenge by 1. Here is an example that is more complicated than this by a little bit. And like, I have a sequence of 3 that I want to go through. Here's the next one. 3.5, 4, I don't know. We'll see what progress we make. Oh, it was doing that the whole time, wasn't it? Doing the weird out of focus, in focus thing? All right, makes me glad. Here is another claim. Claim. If an converges to 0, then the square root of an converges to 0. So, play the same game with the scratch block. I'm going to use the same piece of paper, just upside down. So what do you need to go from? So you get to assume absolute value of an minus 0. Oh, that's just absolute value of an is less than anything you want. Your goal is absolute value square root an minus 0 is less than epsilon. And I think I want to put one more assumption in this claim, which will be clear why I want this assumption in a moment. I'm taking a square root, so I better not take the square root of a negative. This is real analysis. So we'll play the same sort of game as before. And there'll be some moments where we have to make some little tangential steps on some stuff that we should have done before. Let's just see what happens. There's something. How does it simplify?
Positive square root of that.
Yeah. Everything inside's positive, so the absolute values don't matter. Subtracting 0, who cares? So, there's progress. There's as simplified as it gets. The goal is to get this to be less than epsilon, and to do that, I need to connect it with that expression somehow. So there's the thing that you just get to know. And that also looks like it should be simplified, right? You get to know absolute value a(n minus 0) is less than any positive number you want to pick. So, all right, this is just scratch work, so I can be really poorly organized as long as the final track looks okay. How does the assumption simplify?
The same thing.
It looks an awful lot like the same thing. There's just no square root. Yeah, there's no square root in the assumption. So I get to assume a(n) is less than anything I want. Right? The minus 0 doesn't matter. And I said I was assuming that a(n) is bigger than or equal to 0 because I needed to take a square root. And that's true. But happily, that means I don't need to care about any of the square roots. None of them matter. All right, so I get to assume a(n) is less than anything that I want. I would like the square root of a(n) to then be less than epsilon. So let's just try to connect that. And I guess you can assume any properties you want about the square root function. Is that definitely positive?
Yeah.
You can put any positive number you want in that box. It can't depend on big N, and it cannot depend on little n. But otherwise, yeah, epsilon squared seems good. Why is epsilon squared a good choice?
Because you'll be taking the square root of that, or
Cool. This isn't the proof written down, but this is all the scratch mark we need. What do you think? Can you now compose a proof? And let's see. So we know how it should begin. We should consider any epsilon bigger than 0. Is it useful for me to leave this scratch walk still on the screen? Okay. Means I don't get to use all the paper, but I guess I don't need to. We'll consider any epsilon bigger than 0. Now I need a sentence that lets me conjure up a choice of big N. What is that sentence? Oops. Look back at the one we just did for an example. What was the sentence there that let us summon our choice of big N?
So something like since a n converges to a, there exists some big n, so that if little n is bigger than big n, then absolute value of a n minus a is less than. And then I figure out what the number was. Could we do the same thing here? Do we have an assumption about convergence? In our scratch walk, is that all we needed? Yeah, so let's put that sentence. So, tell me what to write.
Give me a sentence that
Since n goes to 0, and there exists, you have to assume that big N is in the natural numbers.
it doesn't need to be.
Okay.
It doesn't have to have that assumption. You get an equivalent definition.
Then there exists there exists a little n bigger than big N.
No, you didn't actually
Big
say
N.
that there exists a big N. Okay. So after there exists a big N,
Yeah.
such that
Little n is
such that whenever little n is bigger than big N, what happens?
bigger than. The absolute value of n minus 0 is less than epsilon squared.
Nice. That epsilon squared is what I know I want because of this. In our scratch walk, what were the things we needed? We used that, like, the absolute value bars go away, the minus 0 goes away. And that led to the conclusion. But along the way, we needed to know that we could get rid of the absolute value bars here. So let's do this bit in blue first. So let's see, since a n is bigger than or equal to 0, this simplifies to how does that simplify?
Well, you know how it simplifies. It's like in scratch walk, right? Does the minus 0 matter? Do the absolute value pairs in that statement actually matter? Yeah, so all I want to do is erase them, because I see that that's what I do in the scratch walk. I'm not trying to be clever. I'm just trying to copy the ideas from the scratch walk down in the order that makes sense.
Then, let's see.
Now let's show that the thing that I want to be less than epsilon is less than epsilon.
You could say that's, I guess equal to the square root of a sub n, which is less than epsilon squared, or the square root of epsilon squared.
Cool. And why is that good?
Because I've shown that the absolute value of the square root is
Yep. So now the last thing we need to do is just include a nice, strong conclusion sentence, and I actually have space to write it. So we're done with the scratch walk. It's all been used. So, for every epsilon bigger than 0, there exists a big N such that for all little n bigger than big N, absolute value of the square root of a sub n minus 0 is less than epsilon. Meaning, square root a sub n converges to 0 as we claimed.
Cool. So, what's the point here? The point is that all the hard walk actually shows up in this scratch walk that I will never see. You don't taunt in the scratch walk. You come up with your choice of big N. I don't need to understand when you write. You figure out what you need absolute value a sub n minus the limit to be less than. I don't need to know how you came up with that. But it better turn out that that choice walks based on your proof. Cool. All right. Ready for one that's like more complicated by one? So this statement we just proved had the assumption that an itself converges to 0. Do you think like the same thing should happen if a sub n converges to like 5 instead? Yeah, right, like square root should be continuous or something. We haven't defined continuous, but like whatever it means it should respect limits. Claim.
Claim. Let a sub n be a sequence. I know I need to take a square root, so I'm going to assume a sub n is greater than or equal to 0 for all n. Let's assume a sub n converges to a. Then square root of a sub n, where had that better converge? And maybe I'll include like one other side conclusion here. If I'm taking the square root of a, it better be non-negative.
All right. Cool. We feeling pretty good? All right. So let's start trying to compose some scratch walk. In this case, it looks like the stuff that I'm trying to conclude is like includes two things. I claim that a is bigger than or equal to 0, and that the square root of a is converges to the square root of a. So they're like two conclusions. Let's try to prove just one at a time. So possible a is bigger than or equal to 0. You can use any limit laws you want right now. So I'm not asking for like an epsilon and proof of this. So you can grab your notes if you want. I think there's like a thing we proved about limits and inequalities, right? in the notes that has something to do with limits and inequality? So, let's just go through the statements in the limit laws and see which of them have anything to do with like inequalities. Are inequalities mentioned in that theorem statement? Nope. So, I think don't care. Maybe I'll come back to it if I can't find anything better. Boundedness. Does that do the job for us? No, because there are no absolute values in what we want right now. Limits and inequalities. Does that look promising? Oh, cool. Cool. Let's see. I have a sequence that converges to A. I know that, I guess it's Bn because it's the bigger one. Do I have Bn being bigger than something? The sequence I have is bigger than something? Is the thing that it's bigger than something whose limit you know? Yeah, cool. So since an is bigger than or equal to 0 for all n, theorem 3.2.5 concludes limit of an, which is a, is bigger than or equal to the limit of 0, which is 0. All right, so we know that the limit's non-negative. Now let's try to do the actual walk. So maybe, well, no, we'll include that later. We get to assume an minus a is less than absolutely anything you want. Our goal is square root an minus the square root of a is less than epsilon. And there's like one bit of algebra that's not deep, but I think I'll give you a hint. I'm not asking you to prove anything right now. If I asked you to simplify that, just two things multiplied together, what does it simplify to? X minus y. Nice. So I guess everything has to be positive for this to walk out, but that's fine. Non-negative. Ooh, so that means I can connect this to this using that. Feel okay right now? Nice. All right, so we want to
I want to transform this into something that looks like that. Maybe we can use this fact somehow.
We can just multiply it by the absolute value of AN plus root AN plus root A.
Cool, let's use that. All right, maybe I'm playing fast and loose with absolute values, but I'm pretty sure that'll walk out. All right,
So I get to know that this is less than anything I want.
this is the thing that I eventually want to be less than a thing. So, this can be as small as I want. There's the thing I want to control. So it's like you want to solve for this in that inequality, right? Because then whatever's on the other side, you just need to make that small. So, how do you solve that for the thing underlined in orange? You divide both sides by the thing it's multiplied by? Yeah, let's do that. All right.
And that's supposed to be like,
A division bar right there.
all right.
So, I can put any positive number I want in that top. Is there a choice of positive number I can put there that would result in that being less than epsilon? Here, I'll make a wrong choice and you'll tell me, yeah.
Wouldn't it just be on
Just epsilon on top? Maybe if I knew that this were at least one, that would do the job.
epsilon times
Yeah, there's something like the intuitive choice. And this is like the super intuitive but wrong choice that I was hoping to get to.
Here's why it's not an acceptable choice. In the statement of the limit, it's for every epsilon there exists a big N such that for all little n bigger than big N. That epsilon comes before big N and little n. I'm not allowed to have something there that depends on the choice of little n. There's the only thing that's forbidden. But that's okay, that's okay. We're all right.
So this denominator, depending on little n, is the only thing that's annoying. So let's focus on that denominator. So I think I do want epsilon times something up here.
So let's look in that denominator. If I can make the denominator, let's see, I want to make the whole thing bigger but still small. So if the denominator becomes smaller but still not tiny, I'm happy. So let's just mess around with that denominator. Tell me how it simplifies. Do the absolute value bars actually matter? No. Root A is positive, root n is positive. Okay. And if I can make this smaller, but still be bigger than something that's bigger than 0, can I just throw out the AN? Is that true? Oh, cool. Let's try that. Let's see what that gives us. So I can make the denominator is getting smaller, so the whole thing is getting bigger. So epsilon times whatever, all over just the square root of A. Ooh, now what do you want to put in that numerator? Ooh. Cool. So, does that now reduce to epsilon? So I think, unfortunately, I've eaten up the time that I would use to get the write-up. So maybe well, first I'll give people a chance. If anyone has like an urgent class that they want to get to next, now's the time to pack. Otherwise, okay, enough people are packing. Try to take this and write out a proof. Can people make my office hour today? Well, you told me when you're coming by afterwards, so we've got a time. Otherwise, can people make my office hour today? 1 o'clock? Very neutral basis. Okay, you're not going to tell me. You don't have to. Take a look at this. Try to find a time to talk to me. In fact, either way, I'd like to see a proof. Come by my office, talk me through a proof that'll make me happy. No points associated with it, but like, I think it'll be useful to do. Yeah, hopefully today may